going to move on to finding x and y intercepts. I'm sure that you've heard of an x-intercept and a y-intercept before. So hopefully this is review. This is still section 3.1. An x-intercept is where the graph crosses the x-axis, and that should make sense, right? X-intercept, it's intercepting the x-axis. Okay, so on this picture, I want you to take your pencil and put a dot where the x-intercept is. That point right there, that's what we call our x-intercept. What is the ordered pair for that x-intercept? What's that ordered pair that points? Tell me. 3, 0. 3, comma, 0. A y-intercept is where the graph crosses the y-axis. So take your pencil and put a dot where the y-intercept is. What is the ordered pair for that point? 0, 6. That is the point where the graph crosses the y-axis. Given you this graph here, I'd like for you to find the x and the y-intercepts, please. Right now, I want you to put a dot where the x and y-intercepts are, and let's identify those ordered pairs, those points. The x-intercept is at what point? Blake? 2, 0. 2, comma, 0. The y-intercept is at what point? Savannah? 0, negative 6. We should be able to easily look at a graph and find those intercepts. Now, do you notice anything about the x-intercepts? 3, comma, 0. 2, comma, 0. What do they have in common? What, Timmy? They both have 0 in that y coordinate of an ordered pair. In an ordered pair, it's always x, comma, y, right? If we're finding the x-intercept, the y coordinate is always 0. And an x-intercept, the y coordinate is 0. What about the y-intercept? What did you notice about those values? We have 0, negative 6. We have 0, 6. The 6 was just a coincidence. But what do we have in common with the zeros? Or not for me, sorry, Blake. The x-coordinate of our ordered pair is 0. 0, comma, y, whatever that y value is. The x-coordinate is always 0. So for the x-intercept, I need to be a little more clear on this. The x-intercept and the x-intercept, the y-coordinate is always 0. And the y-intercept, the x-coordinate is always 0. It's always opposite, isn't it? X-intercept, y is 0, y-intercept, x is 0. So we could easily look at a table, or excuse me, look at a graph and find the x and y-intercepts. What if we looked at a table? Could you find the intercepts at this table? Let's first understand what's happening. It says the table shows the function relating the weight of peanuts in a box and the time in seconds the peanuts have been pouring out of the box. So I want you to picture what's happening. You've got a big box of peanuts. I think of those little styrofoam packing peanuts, maybe. at the very beginning, before they start the clock, before any peanuts have left the box weighs 2,000 ounces. The clock starts, time is passing. What's happening to the weight of the box? It's going down. Okay? The box is emptying. So I want to know what the x and the y-intercept are from this table. So from a mathematical standpoint, what is the x? Let's start with the y-intercept. What is the y-intercept? Thanks.
2,000 and y and x is 0.
You got it. Circle this first order pair. That would be what we call our x-intercept. Excuse me, I said that wrong. That is the y-intercept. When x is 0, y is 2,000. This is what we call the y-intercept. It wants us to describe what's happening at this point in time. Well, when the time is 0 and the box weighs 2,000 ounces, tell me what's happening. Has the box emptied yet? The box is full. The box is full of peanuts. So describe the meaning to the situation. Describe that y-intercept. I'm going to say the box is full of peanuts. You might say the box hasn't begun to empty yet. What ordered pair would you claim as the x-intercept? Alyssa? This last one. 500, comma 0. That would be our x-intercept. 500 seconds have passed, and the box weighs 0 ounces. So what do we know about the box at this point in time? The box is empty, and that would be a perfect description. The box is empty. Let's look at another one. This table or this description says the Torres family is driving to an amusement park. The table shows the function relating the distance to the park in miles and the time in hours they have driven. So they're starting off in their driveway. No time has passed. They're in the car. They're getting ready to go. How many miles do they have left to go? 248. Some time is going to pass. Looks like 4 hours passed, and they have arrived at their destination. So tell me, which of these values is going to represent our y-intercept? The very top one, 0 to 48. When x is 0, we have the y-intercept. So that right there would be our y-intercept. We have a y-intercept. Let's describe that situation. So can somebody tell me what is happening at 0, 248? They haven't traveled anywhere yet. They're still in the driveway. What about the x-intercept? What value would you use to represent that? 4, 0. Can someone describe what that intercept would represent? Alyssa. Sorry, Savannah. Sorry,
They're at the amusement park.
They're at the amusement park. So we should be able to look at a table and identify x and y. So it's just a matter of finding 0. I also want you to be able to look at an equation and find your intercepts. Okay? You guys can put your equations in the standard form. We've been practicing that. You guys have done very well with it. The only thing you're going to need is your finger. That's going to help you find your intercepts, right? Believe it or not. I use them at method what is called the cover-up method. Have you heard of that before? The cover-up method? Who uses that or not? The cover-up method is what I use to find the x and y-intercepts if we're given an equation. If we're wanting to find the x-intercept, I want to solve the equation for x. Take your finger. I want to cover up y. We're solving for x, we don't want y in there, do we? So cover up y. Can you solve that equation that's left? The equation I have left is 2x equals 16. Can you solve that equation? Yeah. How would you solve it? Divide by 2, so x would be 8. Now, when we talk in terms of intercepts, those are actual ordered pairs. They're points. They're ordered pairs. So I expect you to write that as an ordered pair. 8, 0. The x value is 8. The y is 0 for an x-intercept. The x value is 8. The y is 0. To find the y-intercept, I'm going to know where my graph is crossing the y-axis. I don't want x. I'm going to cover up x. So take your finger and cover up x. Can you solve that equation that is left? 4y equals 16? Sure. Solve the equation. Divide both sides by 4, so y is 4. And again, an intercept is an ordered pair. It's a point on our graph. So we want this as an ordered pair. I want to take this a step further and I want you to graph. Okay, that's where the ruler is going to come into play. So we need to draw an x-y axis. I don't need you to do a whole lot of detail on your axes, but I do want you to label your values. I'm going to plot the point of 8, 0. I'm going to put 8 tick marks on my x-axis. The y-intercept is 4, so I'm going to go up to 4 and put it up. Now I want you to take your ruler and let's just draw the line that goes through those 2 points. Finding intercepts are a really quick and easy way to get a sketch of a graph. We'll talk about some other more detailed ways to graph it. This is just one of the ones that typically are pretty easy to find. Let's look at the next example. We have negative x plus 2y equals 3. Is this in standard form?
No.
What do we need to do to put it in standard form?
Multiply by negative 1.
You got it. Multiply by negative 1. I'm going to do that real quick. Now it's in standard form. Let's find our x and our y intercepts. We're going to use the cover-up method. So I want to find the x-intercept first. I'm going to cover up y. What is x? Not 3, but negative 3. This is negative 3. So let's write the ordered pair for that point. Negative 3, comma, 0. Negative 3, 0. For the y-intercept, cover up your x and solve that equation. I have negative 2y equals 3. Divide both sides by negative 2. If you want to change this to a decimal, negative 3 or 3 divided by negative 2, it may make it easier to graph for you. That would be negative 1.5. I'm okay with using it as a decimal, as long as it's terminating. If it's repeating, I want it as a fraction. Okay, so if my y-intercept is negative 3 over 2 or negative 1.5, that would be 0, comma, negative 3 over 2, or negative 1.5, negative 1.5. these points. Negative 3, 0. 0, negative 1.5. Draw the line through. Yes, ma'am.
Wouldn't that be a positive one and a half?
It would. I forgot to bring down my negative, didn't I? Sorry about that. Yes, it would be a positive 1.5. Negative divided by negative is a positive. Thank you, Elena. So there's that point. Try again. What if our equation looks like this? Y equals negative x minus psi. Is that in standard form? It's not. Let's put it in standard form. What are you going to do first?
Add what?
Now it's in standard form. Let's find our x and y intercepts. Find the x-intercept, cover up y. So what's x? Negative 5. So negative 5, 0. Find the y-intercept, cover up x. So y is also negative 5. We'll plot both of our points. I am kind of picky. I really want you to use your straight edge to draw your lines. Stop here. Remember, if we want to find x and y intercepts from a graph, we can just use the cover-up method. If we're looking at a table, if we're looking for the x-intercept, what do we look for?
Top and bottom.
Well, it just so happens there at the top and bottom. It won't always be that way. If we're looking for the x-intercept, look for the zeros. If the x-intercept is there, the y is 0. If the y-intercept is there, the x is 0. I have some problems for you guys to try. They're going to be out of your book. I've got some graph paper already printed for you, so you can graph one here. The bell is going to ring here any minute. I would like for you to go ahead and return calculators and rulers. My rulers over here in this green box. They're on the right shelf. Let's stick those in there if you would. That's so you already printed your homework in. You're good.